Okay, so in this question we've got to find two angles, PQR, PQR, the angle at Q, and ORS, ORS, that angle there. Okay, what strikes you here, although you're not told, you can identify, first of all, you've got two isosceles triangles. ORS is isosceles because OR is a radius and OS is a radius. And we've also got ORP is isosceles because OR is a radius and OP is a radius. Other things to think about before starting the question, we've also got a quadrilateral PQRS. All 4 points are on the circumference, so it's a cyclic quadrilateral, as we're looking maybe to apply that rule at some point. Let's start writing on some angles that we know then. Well, look at the triangle PRROOP. So if the length OP is equal to OR, because they're both radius, or radii, sorry, then the angles must also be equal. We've got 40 degrees. If you start to have a look here, we've got this diameter PS. Now PS subtends to the circumference at R. We know that if it's a diameter, that total angle there must be 90 degrees. So if we've already got 40 on this side, that's got to be 50 degrees there. So we've already found one of our angles. ORS has to be 50 degrees. Now what we can start to do now is we start to fill in the information on this triangle here, so we'll just use a different colour to identify that. We're going to look at the triangle ORS, SO. And here we've got two equal lengths, both again radii. We've got a radii there and a radii there. Now if the angle at R is 50, the angle at S must also be 50. Okay. Just for a sense of completeness, we could say now that's 80 degrees, but I'm not sure we need that for this question. But don't be afraid to fill out extra details, that's not a problem. What we can start to do now is start to look at our cyclic quadrilateral. So we've got Q to P, P to S, S to R, R to Q. Now opposite angles in a cyclic quadrilateral must add up to 180 degrees, and if the angle there at S is 50, the angle here at Q must be 130 degrees, and that's our second one that we wanted to find out, 130 degrees.